This video will talk about equivalent statements. Two statements are equivalent if they have the same truth value at all times. We use the symbol that kind of looks like an equal sign with an arrow on each end when two statements are equivalent. So let's decide if the statements P implies Q and not P or Q are equivalent. Alright, so if we're going to decide if these are equivalent, it's really hard to just look at them and see. Like when I look at them, I have no idea if P implies Q is equivalent to not P or Q just by thinking about it in my head. But I can test the truth tables and that will really help out. So let's start with the P implies Q. All the time when I just have two statements like P and Q, my truth table is really boring. It's the same thing. P is true, true, false, false. Q is true, false, true, false. So this is something you need to have memorized of how to set it up. Sometimes in the homework you'll see it'll prompt you for it, but not always. And definitely on the test there'll be some that I do and some that I don't. So you need to know how to fill in truth tables. So make sure you're practicing that. All right. So now that I have the true, true, false, false, true, false, true, false, I want to think about the connective, which is the implies. With implies, true implies false is false, everything else is true. So true, true is true, true, false is false. That's the one you're paying attention to with imply. False, true is true, false, false is true. All right, so let's keep our comparison. The other statement, not P or Q. All right, this time I need to start with P. I need to have P and Q. I see this negation for P, so I need a column that'll be not P, and then I want to put the two things together, not P or Q. So once again, boring starts, right? And I want you to think boring, it's always the same, always the same. That really help you if you just memorize it, always the same. So P is true, true, false, false. Q is true, false, true, false. All right, if P is true, true, false, false, not P is the opposite, which means it's false, false, true, true. I'm taking this column here for not P, and I'm putting it together with this column here for Q, and I'm using the connective of or. So or just needs one true. So true or false is true. False or false is false. True or true is true. False or true is true. Okay. Now that I have both of my truth tables, I want to compare the last column in each of the charts. So in this one, I have true, false, true, true. On this one, I also have true, false, true, true. This says, because the last columns are equal, the statements are equivalent. So let's try it again. This time my statements are P or not Q, along with not P and Q. And I want to decide if they're equivalent. So once again, I'm going to do two truth tables. So the first one is going to be for P or not Q. I know I need P, I know I need Q, but because there's a negation, I know I also need not Q. So I start true, true, false, false, true, false, true, false. All right, this time it's the Q that's negated, so true, false becomes false, true, false, true. I'm using or, and I'm looking at the first column P with the third column not Q. True or false is true. True or true is true. False or false is false. False or true is true. Second truth table, I'm using not P and Q. So start your PQ again. True, true, false, false, true, false, true, false. Not P, false, false, true, true. So now not P along with Q, but pay attention that my connective this time is and. So for and, I need all true. So true, false, that's false. False, false, that's false. True, true, that one's true. False, true, that's false. So let's look at the last column. I have true, true, false, true. Let's look at the other last column, false, false, true, false. Those are not the same, right? So these, since they're not the same, we can say the statements are not equivalent. All right. So let's add some words to it so this makes more sense. So let's start with my first statement. If you are allergic to seafood, then you can't eat shrimp. And my second statement, if you can eat shrimp, then you aren't allergic to seafood. So we want to say, are these the same? Is it the same to say if you're allergic to seafood, you can't eat shrimp? As it is to say if you can't eat shrimp, then you're allergic to seafood. They sound kind of similar, but because of the order and because of the negations, they may be different. So to figure this out, the first thing I want to do is change this to symbols. I'm just going to go in order. The first thing said you're allergic to seafood. Let's call that P. The second thing says you can eat shrimp. I'm going to call that Q. I do know, and I can see it, that the first thing in the first sentence, it says you can't eat shrimp. I don't like to use negations in my simple statements or in my symbols, so you won't see me do that. You'll see me take that out, make it a positive statement, and then you just use negations as symbols. So now when I look at statement 1, it becomes P implies not Q. When I look at statement 2, it says Q implies not P. All right, so now I want to know, is P implies not Q the same as Q implies not P? This time, to do it a little different, I just made one big truth table instead of 2 separate ones. And you can see I started P, Q, because I know I need them. So P is true, true, false, false. Q is true, false, true, false. That's the same old, same old. Not P is false, false, true, true. Not Q is false, true, false, true. Go back and look. My statements are P implies not Q, Q implies not P. That's what I have here. P implies not Q, Q implies not P. So pay attention to order. Remember that order is important when we look at the implies. It's the only one that order matters for. And, or, if and only if, it doesn't matter. But when I'm using imply, I have to pay attention to order. So I am starting here, and I could circle them for you if that helps. I'm looking at true, implying false. I know true implies false is false. Then I have true, implies true. I know that's true. False implies false is true. False implies true is also true. Okay, so that's my false, true, true, true. Then the other way, I'm going from Q to not P, and these two are beside each other. So this is true to false, that's false. False to false, that's true. True to true, that's true. And then false to true is also true. Look at these last two. Both false, both true, both true, both true. These statements are equivalent. So how about you give it a try? I want you to determine if these statements, you buy the house if and only if you have a 20% down payment, and you have a 20% down payment and you buy the house, are equivalent. So give yourself some time. You should be making a truth table decide. Do not just tell me yes or no. That's not going to cut it. You have to show some work here. All right, so write out your truth tables, do your true false thing, come back and check out with me what the answer is. All right, so I decided to let P be you buy the house. Q is you have a 20% down payment. My first statement, because it says you buy a house if and only if you have a 20% down payment, was P if and only if Q. The other one says you have a 20% down payment and you buy the house. That's P and Q. It's really Q and P, but same thing. Order doesn't matter for these. All right, so no negations in any of this. I'm just going to go ahead and go true, true, false, false, true, false, true, false. The if and only if, remember that means matching. So true, true is true, true, false is false, false, true is false, false, false is true. So matching are true with the double arrow. And then P and Q, I need them both to be true. So this is true, this is false, this is false, this is false. Only that true, true is true. All right, so this starts off pretty good. Trues, false, false, but this last one right here is where it all falls apart. Because these don't match, the statements are not equivalent. All right, one more thing to talk about in this equivalency, that was a hard word for me, is De Morgan's Law. De Morgan's Law should be a blast from the past. We talked about this with set theory as well. And what it just talks about is what happens if I put a negation through a parenthesis. So if I distribute this through, if I put the not through the P, not through the Q, it is going to switch or to and. So the negation of P or Q is not P and not Q. The negation of P and Q is not P or not Q. These rules are sometimes helpful when you're negating compound statements. They just sound better, and I really like them. So like, let's consider this statement. Your paper was late and you will receive a letter grade deduction. The negation of that is your paper was not late. Do you see how this and became an or? You will not receive a grade letter deduction. I think this is a good way to say things, is using De Morgan's Law. If you didn't use De Morgan's Law, the negation of your paper was late and you will receive a letter grade deduction would be, it is not the case that your paper was late and you will receive a letter grade deduction. I don't think it's like regular talk. I don't even know if that's the right way to say it, but it's not normal conversation for anyone to say it is not the case. That's kind of a legalese kind of thing to say, and that's not what I'm trying to teach you in this class. I want to teach you that when you're negating a whole statement, that you really have to pay attention to the change in the connective. That connectives and will change to or will change to and. So I want you to remember that or goes to and goes to or, and I want you to try to negate these two statements for me, and then come back and check with me how you did. So let's start with your payment is on time or you will have a late fee. All right, so if I negate it, your payment is not on time and you will not have a late fee. Doesn't sound like what you think the opposite is, really, right? Because you kind of think if my payment is not on time, I'm going to have a late fee. So don't worry about the logic of logic. I know that just sounded weird. But you don't always have to make the things make sense in your head. You just have to do what I ask you to do. So I asked you to negate the statement, and you did. So instead of your payment is on time or you have a late fee, the negation, your payment is not on time and you will not have a late fee. All right, number 2, even though it says number 1, let's make that a 2. You missed your plane and the next flight is in the morning. Negation, you didn't miss your flight or the next flight is not in the morning. Okay, doesn't have to make sense. That's the biggest thing I always tell people with logic. Logic is not logical. Just do what the problem says, and then you'll do well on the chapter.